1 2 1 2. What time is it? 5:38. Yeah, we still got time. Test 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 test. All right. For the friends that are on the live stream, can you hear me? And if you can, give me a thumbs up in chat. I'm stepping away right now. Can one of you try the GDG? Hmm? Yeah, good call. Oh, we got thumbs up in chat. All right, cool. Thanks, everybody. Sorry, we're just slowly getting situated. Wow, we actually got a. This is what happens when you just keep your head down in the keyboard. You turn around, it's like 50 people behind you. Holy crap. Did you decide if you feel comfortable with this?
Oh, I didn't even try them.
You want to try it?
Sure.
Yeah, let me turn off the audio real quick. cool. This is still working. Don't worry, y'all. We're still here. We're just slowly getting set up here. We'll probably start here in the next 5 or so minutes. Cool? So see you in a minute. Or a few minutes. Come on. Sit up here. Come on. Come on. You're organizer. You're along with us. Dan will be up here. Come on. Alrighty. So, do you see bars moving on that screen down there?
Yeah.
Cool. All right, we're live. All right. First event of the year, so we're a little rusty. You know how to get this thing going. You know, the holidays are officially over. So, hey everybody, thanks for coming out to the meetup. This is the GDG Cloud, GDG Chicago, and the Grafana and Friends meetup. So this is awesome. I love how we're partnering together. It's kind of the theme we had at the Dev Fest this past year in October? Sorry, it's been a long time. So we hope you all had a safe and wonderful holiday season. We hope you had a great new year. And here we are in 2024, the land of generative AI. So what are we doing? Not talking about generative AI. We're talking about some pretty cool Grafana stuff. If you need the Wi-Fi at all, it's been up there for a minute. It's tag guest, and that's the password. So if you need it for whatever reason, there you go. Today we have a great talk from our friends at Grafana talking about queries to pixels. Basically, I know who here uses Grafana in their day-to-day? Like, raise a hand. Good chunk. Oh, look at that. Some excited people in the back. This is going to be a pretty interesting talk because it's not just going to be talking about how to use Grafana, but it's mostly going to talk about how this actually works. How does all those pretty lines and visualizations and renders actually happen? So it's actually a pretty cool, I'm very excited, so I'm happy to have Leon here today to present. If you are on X, I guess at this point we could call it X because it's been about a year, feel free to follow us. There's also our meetup links down there, so feel free to join our meetups as well. We always do this. Code of conduct. Look, it's simple. We don't have a big list. Be nice and excellent to one another. We're all here learning. We all have different skill sets. Some of us are uber awesome people. Some of us, this is our first meetup or first time just getting out there into the tech world. Be cool to one another. That's simple. If you see something, say something. I'm Joel. Amanda. There's Amanda. And we have Dan, who also was there if you were checking in. We're here. We're here to make sure you all have a good time. At the end of the day, harassment's not going to be tolerated, so just be nice to one another. And really practice saying yes and. When we say practice saying yes and is always foster communication and conversation. Don't just say, well, you're wrong. This is the way to do it. Understand that everyone has a different perspective. See what they do. Someone working in a financial space is completely different than someone working in healthcare. But at the end of the day, we're working together to, just learn and do cool stuff together. I mentioned this before, but welcome again, Amanda, our latest GDG organizer. So round of applause. Thank you. Just some announcements. Cloud Next 2024 is happening April 9th through the 11th. If you want to go party in Vegas, go learn in Vegas, feel free to ask your employers to potentially go. I know it just seems like it's been recent, but I'm looking forward to any new announcements in the last 6 months. Yet to be fully fleshed out, but we're intending on doing an International Women's Day event sometime in March, hopefully March 8th, but we'll figure out the details. Amanda, anything you want to add? Or we're still kind of planning for it?
We're still putting it out, but please show your support and please come.
Yeah, so we'll be sure to send that out through the same means how got you here. So if you're interested in that, we would love to see you all there. And without further ado, let's hand it off to Leon from Grafana Labs to talk about from queries to pixels. So Leon, let's give him a round of applause. Let's do a little.
All right. Hi, everybody. Thanks for coming. Let's see. We gotta switch this over. I think a couple buttons. Awesome. All right. So, from queries to pixels. I named it that way because that's kind of the layer that I work at in Grafana. I had a couple of Grafana users approach me earlier today and ask me how do I migrate from Splunk or something. I can't answer that because I work the very top of the stack, and once the data gets to me, I don't care where it comes from. So this is kind of going to be, it'll be fairly technical, I think. There's going to be some code. So if you know JavaScript, it'll help. I think that's about it. So this is for all of you, especially since this last point, I saw pretty much everybody eating pizza, so I think we're good. So this is what most people think, or what most OSS users think of Grafana, and this is mostly correct. But as an employee, I actually see it kind of like this. So Grafana is kind of like the tip of the iceberg to this huge observability stack that's open source. I think 80% of the code that we write is open source. Only some of the components that we use for hosting the data that you send to us are closed. There are some additional enterprise integrations with things like SAP and other enterprise authentication methods that are closed source. So what's cool about Grafana is that you can keep your data where it is, right? So we don't insist on ingesting your data into our infrastructure. We can if you want to, but you could also self-host. You could run it yourself, or you could run Grafana on our hosted platform, and there's private data connects, which you can actually pipe data into it. So it's composable. Most of the use cases have been for infrastructure monitoring, but we've been expanding rapidly in the last few years. Performance testing with the acquisition of K6, application observability, and incident response management. We recently acquired Pyroscope. Maybe some of you have heard of it. It's heavily used in profiling, so finding performance issues in your code. So we're doing profiles now. Okay, rich ecosystem of extensions. So you can write plugins, publish them. Others can consume them. There's apps, there's data source plugins. So if you have some weird data source, you can write your own plugin for it. So it's a true platform. You could do visualization panels. So we have core panels that we have, but they don't support everything. They're kind of meant to support the 85-90% case, but there are definitely visualizations we don't have yet. So like violin plot, we've had people ask for that, and we don't have it yet. So I think there's maybe a Plotly extension you can use, and there's a bunch of options for you there. I think there's also theming extensions that I'm looking down here. I ended up adding it at the end. Let's see. I haven't worked anywhere that you've heard of, I don't think. And I've been doing web dev for quite a while. I think I still have repressed memories of trying to get CSS into shape to work in IE6 and Firefox 1 at the same time. So yeah, definitely some mental scars there. Hopefully we'll not have to revisit that ever again. I have been a data viz engineer at Grafana since 2020, and there's going to be probably an unhealthy amount of memes in this place, in this presentation. I'm not a public speaker. I'm an engineer. I'm doing my best. So this is my actual Slack icon in Grafana. So as I mentioned, I work on the data viz squad. If this nice rainbow layer cake is the Grafana stack, our team of 7 people works on the sprinkles and maybe a little bit of the icing. If Grafana, the app itself, it would be probably the icing and a little bit of that red velvet in there. Everything else is infrastructure, databases, microservices, the entire ingest pipeline that we have for huge customers, airlines, banks, healthcare system, healthcare providers. What does data viz do? So the 7 of us actually are responsible for probably most of the panels that you're familiar with. We maintain them, we fix bugs, we write new options for them. Sometimes they're from user requests from meetups like this. People will come to us with new use cases and they say, we really want to do this, but we don't know which transformation to use, or we want a violin plot. And then we open an issue and we watch it for a while and see how many other people say they want one. And if they want one, then it ends up happening. The other thing we do is also data transformations. So data sources, you can plug any data sources in, right? And you can write queries that return data in different shape from these data sources. And the panels only support maybe one or two different shapes of data. So you may have to do some transformations on them to get them into that shape for a bar chart or for time series or for scatter plot, right? They don't all look the same. Part of it is performance related, because if you had one shape, then you would have a terrible experience in some of the panels and a great one in others. So I think I described what it says here. So okay, the data format. 1 second. Data format is data frames. The way that I like to explain it is kind of like SQL tables, I guess, or just tables. The only difference is the column names, they have labels additionally. So you could treat the column name plus the label, the unique label set as a single, as a unique identifier, right? So typical time series frames look like this. You may have one, and it may be like a metric like CPU usage over time. So in the time column, you will have nanosecond, or not nanosecond, you'll have millisecond epochs, and here this is just regular Unix epoch timestamps. And it could also be population, and it could be segmented by country and gender, for example. So it doesn't need to be specifically CPU. Going forward, I may refer interchangeably to these things as fields or series. They're kind of the same because if you look at this, we actually build the, you don't ever, when you feed data into Grafana, you don't ever go in and you don't set up that you have 3 series and this is what it's called, right? It actually takes it from the data that it sees. So the way that it does it in time series panels is it'll take all numeric field or all numeric field and generate series out of them, and that's what you see in the legend. So we do have, you could actually have frames without time. So these are time series frames, but you don't need a time column, right? As long as it's columnar data, for example, for scatter plot, you can have a single data frame per series that you have. So it'll have XY pairs. Or you could have XY pairs with another column for point size, and you can map that to a point size and as well as a color. You can have a color column or field. So I think I mentioned this actually, I think I did, is that most time series databases are schemaless. So when you zoom into Grafana, or Prometheus, for example, you may not have the same series that's consistent across the entire lifetime of the database, right? So you may zoom into last week and you're going to see one series appear there that doesn't exist this week. It wasn't reporting any data. So during zoom operations, we actually have to dynamically reconfigure the schema on the fly when you zoom to accommodate these cases. So there's not a fixed definition there. So one of the things that, sometimes you're like, well, it seems kind of limiting is that you only have tables, right? How do you store, for example, tree structures? We have a flame graph panel that can render trees. So it renders profiles, right? A profile is a tree of function calls. It's a call stack, and it shows you what amount of CPU time or memory was occupied by that slice of the process or that function. So the way that you can actually store a tree in a data frame is it's called MPTT. It's kind of a weird name. It's Modified Preordered Tree Traversal. It's kind of a fancy name for something that's actually fairly simple, is that you basically trace around the edges here. It's going counterclockwise as you go. You enumerate 1, 2, 3, 4, 5, 6, 7. This is effectively just a depth first traversal of a tree, and you just enumerate the nodes using a global identifier, and that becomes storable in a data frame, and it just looks like a table. And you could reconstruct this tree and then build this visualization either directly from that table, or you can build the tree again. There is another name for exactly the same thing. I don't know why there are two names for this, but this is a different way of visualizing the same exact thing. The categories here are different, but you could just go left to right and enumerate. And it's called nested set on Wikipedia. Same thing. Data flow. So data flow is how the data actually gets into the visualization at the very end. And this is something that even internal Grafana engineers are often confused about, because it's not super straightforward how this works. Like, you know that it gets there, but there's a bunch of different things you can put into here that you don't know when they happen. So this is kind of going to go through and put it in order. So what happens first is the queries get executed by the dashboard. They're not executed by the panel. The panel holds the config, right? So you go in the panel, you configure your queries, and it stores that query in there. It may have template variables, which come from the dashboard. The template variables are the little drop-down selectors you can have at the top of a dashboard. So the dashboard infrastructure is the actual thing that executes the queries. So when it does this, it evaluates the template variables, it replaces them, and it does that. Then it goes and it takes an instance of the data source plugin, whatever that is. So in here, the data source plugin provides its own query editor, right? So SQL is going to have one, Prometheus is going to have another one, Influx is going to have a third one. The data source may not even may not have a query. You may put together an API call, right? The response might be JSON or it might be XML, and you need to somehow parse that into the resulting data frames. So this one specifically actually has a query builder in it as well. So it has both a code editor and a query builder. So what happens next is the transformations get processed. So once the data source puts the data into more or less the right shape, you may not have the full facilities in there to do all of the transformations in the data source that are required for all panels, because it's diverse. So you could add transformations additionally, and they get run immediately after the data source plugin returns the data. What happens next is there's a thing that in the panel options on the side, there's actually two different sections, and I think that we're going to be improving this soon, because it's not obvious which of these applies to the fields and which of these is just a general panel option. So like I was explaining before, we automatically generate the series from the data that you have, right? So you have numeric fields. So what you're seeing here is the standard field config, or it's a field config that gets applied to every numeric field that we find, besides time, in time series at least. If you change line width here, it changes for all the series that we generate. If you change fill opacity, it changes for all the fields that we generate. If you want to do something different for a specific series, you actually have to match it and then override that default configuration, right? So this is what overrides mean, is that the overrides get run on top of this field config after it gets processed. Then we see if you've selected to match by field name, and say you want a different line width or a different line style, then we apply that on top. Finally, the actual panel options is kind of difficult to see. I've tried to kind of highlight these two. So tooltip and legend don't relate to any specific series. So the options in there are like, which mode do you want? Do you want the tooltip to be in all mode or single mode, or do you want it to be hidden? The legend may have, how do you want to render it as a table? Do you want sorting in there? Do you want calculations? Do you want to see like what is the last value of each series, what the min or the max is? So those are not series specific. Those are just panel options. Hopefully in the future we make this distinction more clear. Right now they're kind of intermixed. And finally, once you have that, the final field, the data that is infused with the field config is then fed into the panel with the panel options, and then the visualization decides what to do with all of that. So it will read all of the fields. It will see what color do they have assigned to them. By that point, everything has already been boiled down. All right, let's see how this works. So a lot of this is just going to be live. So this is a Grafana instance I have running on my machine because, well, I build Grafana. So let's go in here and take a look. I've written my speaker notes kind of here of what I wanted to show you guys. So in here, you can do table view, and it's going to show you the raw data that comes in. You can see that there's actually a few different series in here. They actually come from different data frames. So the table can't show you multiple tables, right? It's one. And if we were to show you all of them, they wouldn't fit on this page. So there's actually a frame selector down here which shows you which frame you want to look at. So in this case, this response had 4 frames in it. And each of them got converted into a series with timestamps and values. Next, let's take a look down here, and I'll take a look at the different data sources. So this is Prometheus. Oh no, let's look at this. So have you guys used Panel Inspect? Anybody? Has anyone seen it? Okay. So Panel Inspect has a lot of interesting things in it. You can view all of the stuff that I've been talking about in Panel Inspect. It will show you how the data gets kind of down into the panels. Panel JSON is literally the configuration that you have in here. It's these settings that get stored that the dashboard picks up. Yes. 1 second. So in the data, you get a table, which is basically the same as the table view there. In JSON, what you have is you can go down and do data frame JSON. Data frame JSON is actually the data that comes straight out of the data source plugin. It is before transformations. And we actually use this a lot in Grafana to debug different visualization issues. So if you have something that looks broken, if the line is going off in a weird direction, or it's not, the axis is a weird like level or something, we've asked previously for users to give us a dump of this JSON. They can look at it, they can clean it up. It actually has, I think it has the queries in here that were run as well.
Is it common for like if debugging a panel, like I could anonymize the data, send it over to you folks?
Yes, we actually have a tool to do that. I think it's in support. And what it does is it has the ability to randomize data here. And it does it pretty well. It's not perfect, and you could review it before that, but it creates a debug dashboard that has the data embedded, so that like previously we would have to ask people, how can you give us a CSV of your data, or give us your panel JSON, and then separately give us like this. Actually creates an entire debug dashboard, so you could preview it. And this is basically what we get, although here it doesn't look like it's rendering anything. Yeah, it might be the time. Well, here it's already embedded, right? So here the data is going to be fixated. It's actually the same thing as get help in here. Let's just do apply and refresh, and then we'll take a look at that. So if you go to more and get help, there is some data. Let's try to preview it. There you go. Okay. So this creates a dashboard that you could either preview or you could attach it to a GitHub issue, and we will take a look at it. And it's much easier for us to reproduce. We pull it up, we see what's wrong. We don't need to try to figure out what your data source is doing because we already have the data there. Okay, let's see. What mixed data sources? Have you guys used mixed data sources? Do you know that they exist? All right, mixed data source. So here you have a panel with a single data source. It's the demo of Prometheus that I put in here. You could drop this down and switch it to mixed. And what it does is this becomes just one data source and you can add another one. So you could add another query and then you select another data source. In this case, it's test data. We use this a lot. There's a lot of cool stuff in here as well. The reason you don't see anything in here is because it's super small. The range here is like 30,000, right? So if we do start value, let's say, let's do 10,000. We have a straight line there. Minimum, let's do 0. Maximum, let's do. There we go, got a little snake going there. So you can actually visualize multiple data sources in one panel. You don't need 2 panels for it. Another cool thing.
How you can correlate like something like I don't know, like a GCP metric and also like a Prometheus metric, kind of overlaying it.
Yep. So you could do them together. So another cool thing you can do is let me remove this. You can visualize the same data in different ways, right? So you can, what you could do is you could add a new panel, add new visualization, and what you could do is you could select a dashboard data source. What a dashboard data source does is it allows you to pull the same data from a different panel. But instead of doing it into a time series, in some cases that might make sense because you might want to apply like a different transformation to it. You may want to do an average or max or something. But you could also do like a table, right? Let's say that you want to see raw data from the same query. So you don't have to query this twice, right? So you'll refresh this and it'll give you the same data both in a table and in a time series.
Does that have less impact on kind of back-end Prometheus, or is it still one query?
It's one query, right?
That's awesome.
So
huge if you have very big dashboards that are very intense.
Yep. So let's see, random CSV entry, CSV file, raw frames. One thing, yeah, so the test data source, I've shown you the raw frames. What you could do is panel JSON, data frame JSON. These are the raw frames that come into the panel. What you could do is you could do add visualization, and you can select test data, and then you can select raw frames, and you can just paste that in there. And it works. So this is kind of doing the same thing that the dashboard, that the get help thing does, the debug thing does. It actually embeds the data in. So we always have the test data source available. So this embeds the data into the panel config.
You know, like how when you're like developing, you kind of like create your ideal schema with some fake values and then
Yep.
see how you would.
So we have a bunch of GDev panels that are in the open source repo actually that you can take a look at. So I can load this. I can show you what that looks like. So GDev dashboards, this is something that we use for our own regression testing to make sure that nothing like goes weird, because there's really like an infinite number of use cases. So we have a ton of panels that have all sorts of different visualization settings at the same time, different combinations, things that have been reported as bugs before that we can look through and make sure that, you know, the thresholds still work as they need to, that the time regions still get rendered, hue gradients. You could actually, there's a script, I think it's scripts devenv.sh. If you run that, it will actually provision all of these into your Grafana instance. So if you don't know what you're starting with, you could actually run that script and you can go in and explore already made dashboards. You don't need to start from scratch. You can inspect like, yeah, there's a ton already in there. Yep. All right, let's see. Performance, okay. So users give us crazy stuff. And we sometimes give them advice, don't do select star from queries, and they say, but we really want to see, or select star from metrics, they say, we really want to see all of them. And we're like, well, you know, especially if you pay us a lot of money. So yeah, we have customers with 10,000 dashboards, you know, auto-generated, but hundreds of panels per dashboard, that's real, because you can have collapsed rows and you can scroll down and expand the ones that you want to see. 1,000 to 250,000 data points per query is not unusual. Prometheus will stop you from doing that. Prometheus has like a hard limit of 10,000, I think. It'll yell at you if you do more. You could probably remove that if you go into the config. Also, the panels actually have, there's a drop down in here. I will show you. If you go in here, and this depends on the data source that you pick because they don't all support this, but there is a max data point setting here. So for example, we have this Prometheus data source, right? Not in here. This is not a real one. So if we go in here, you can actually change the resolution of this. The default resolution that it does is it sees how wide your panel is, it sees how many pixels there are, and it sets that to the max data points. So you can see this thing is 884. If I change it, you can see that it changes. But you can say, hey, I don't want that much data. I only want a query at a step value of 100, or I only want like 10, you know. So this is useful if you want to keep it static. I mean, this isn't maybe that useful in all scenarios, but for sure it is in some. Chain transformations or live refreshing at 5 seconds. So before I started at Grafana, the fastest refresh you could do of a dashboard was 5 seconds. That's it. You could manually sit there and refresh it, but you couldn't do more. Then, when I came on board, they were like, we want to do streaming data, which is, you know, and the target was 20 hertz, which is 50 milliseconds. 50 milliseconds, 5 seconds, their charting library died whenever they tried to do anything close to that. So we replaced it, and we're going to see that later. Chain transformations. Even with live streaming, you could have a bunch of transformations, and users don't always pick the best ones because it's kind of difficult to pick the best ones. There's a lot that do a lot of similar things in different ways. So we've seen, you know, chains of 5 or 6 of them, and I mean more. You're like, what are you doing? You could do this in like one of them with 2 extra settings, but it has to work well. And viz rendering, obviously, drawing the wiggly lines, and data interaction when you're moving your mouse cursor around over a panel that has, you know, 100 series, and each of them has 2,000 values, and you want to have real-time feedback of your cursor going around. That's on us too. So everything we work on in DataViz is actually kind of like, there's no premature optimization because users give us whatever the hell they want, and they just want it to work. And I'm kind of done being surprised with what I see now. It's pretty insane. So why optimize? I kind of went over that. It's painful to use, right? And Grafana is a tool, and if the tool sucks, you throw the tool away and you find a different tool that works for you. So we want to make sure that Grafana, you know, stays exceptionally good, so that people don't need to look for some other tools. And I hate using slow tools. I get super annoyed by slow web apps. Craft, well, you know, I spend 10 hours during the weekdays doing this thing that I do, and you know, why make a turd? I want to make it really good, so I take pride in what I do, and I don't want to settle for mediocrity. Battery life is something that you probably won't hear very much from front-end developers. They usually don't care, but in reality, like, even though when you click, if something takes 100 milliseconds or 10 milliseconds, you won't notice it. But your battery life will. We have users that use Grafana on tablets in the field. And if you're making a certain common interaction 10 times slower, then, well, their batteries die. And memory use, this is another one that's not obvious. If you're using an app on a memory-constrained device and you switch to another app, like your camera, it will unload the other app if it's too heavy, right? If the app is using way too much RAM, it can't unload part of it. It has to unload the entire thing, potentially. So when you switch back to it, so let's say you use Grafana and a camera app, you switch back to it, Grafana has to reload from zero, basically. It has to reinitialize, and that sucks. So, memory use is also important to watch. Some things that we do have control over and that we target for optimization, initial app load, smaller bundle sizes, code splitting, async loading, reducing, removing deep dependencies. When I first started, I think I looked through the dependency graph and I probably shaved about 2 megs off of the bundle size, which is pretty crazy. I think that since then, we've kind of gained some of it back, because we do add more features and stuff, so we just have to do housekeeping periodically. Data transformation is ripe for optimization because it loops all of the data, all of it. Everything you give it, it loops over. So anything you do in that loop is extremely performance critical. Viz rendering, the same thing. When you're rendering lines, loops over all the data. And UI interactions, as I mentioned before, mouse move. You realize you can resize your panels smoothly, right? It's not like you resize the panel and then it catches up to you, like once you let go of the mouse. It actually resizes as you move it. That means that we're re-rendering that entire data set for every pixel that you move your mouse. And hundreds of times per second is, easy. Rather easily that happens. So trying to stay as close to within, a frame of latency is the target. Obviously not always possible because there's just a lot to do. So one of those strategies for optimization is called decimation. So if you have 20,000 data points and you only have 100 pixels or 1,000 pixels, how do you render that, right? Well, you think, you sample it. Well, you can't sample it because then you might sample away the spikes, and that's the interesting stuff, right? You want to see the spikes. So what data decimation is that for every pixel that you have, it'll basically aggregate your data, and it will get the high and the low, and the in and the out of each pixel, and that's how it draws the lines. So you never lose the spikes. There's no sampling. It's not sampling. That would be terrible. There's some other strategies to do this. Grafana uses min-max, or rather the charting library in it uses min-max. There's also M4, which I actually think is kind of the same. I have to research that, but and LTTB is another one that's really cool that I've been meaning to try. Data points that are rendered on the charts. The old graph panel, you could either always render them or never render them. And that doesn't work for dynamic data. That means you can't reuse the panel for different data sets. Because in one data set, it would be great. And in another data set, you would have way too much. And it would render 20,000 data points on the graph because you wanted another dashboard to render 100 or a couple hundred. So in the new panel, we actually have adaptive rendering. So you can see that these data points actually disappear once it gets too dense. Streaming. Streaming data frame is a data frame that stays in memory. So Influx has a telegraph protocol where you could basically receive data from IoT devices over WebSocket or whatever. And what we do is we keep a data frame in memory at the dashboard level in the panel query runner, and it acts as a circular buffer. So it will keep adding to the frame, and then it will just send that frame on down to the panels, right? So and then the whole process just happens again, and you get a consistent update. So one interesting thing that we do, and this is I don't know if this is our invention or not, But how do you detect if your UI is not keeping up? Because your WebSocket could be emitting way too much data. You can't render all of it fast enough. Your dashboard is super huge. You're streaming everything. So what we do is we do a set interval. It's pretty simple, is that we do a set interval on the main thread. And it basically keeps track of the last time that it fired, right? So this is 100 milliseconds. It'll run 10 times a second. It's super cheap to do when there's nothing going on. And it will always be within about 1 millisecond. It'll be either, since last one, it'll be either 101 or 90, 99. Once you start loading up the main thread with other tasks like rendering, layout, etc., this will start dropping. So what we do is we detect this and we buffer and we do not send that data frame down to the panels until we see that we've caught up, right? So until this thing goes back to 199. Something else that actually ended up using the streaming data frame after we added the streaming functionality is Loki, which is our logs data source. What this does is logs sometimes take a very long time to query. There's a lot of unstructured data there, and depending on your query complexity, it could, like 30 seconds is not unusual, depending on the size of the customer, obviously. So the system is very fast, but we also have very big customers. Normally, you would just wait until the query is finished, and you would see nothing until then. So what chunk splitting does is it takes a time range and it runs this query in multiple chunks, right? And this is, I guess, unable to play for some reason. But if it did play, you would see it going boop, 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 boop. There, that's my best impression of it. Incremental querying in Prometheus data source. I mentioned this because I worked on it. Usually, Grafana will query the entire time range. You have a time range for a query. It'll query all of it. If your refresh period is 5 seconds, it's going to take it. It's going to move it over 5 seconds. It's going to requery that whole time range again. We thought, why? Why do that? Like, we already have so we do that. We basically take what we have, chop it off. We see what we don't have, query that. So instead of transferring like 3 megs potentially for a query and having it take a long time, we're now like, a few dozen kilobytes per refresh. If you have, my button doesn't work anymore. Now I'm sad. All right. Let's do F11 slideshow. Oh, I think that, okay, let's come back out of here. I know I have a streaming demo in here. There you are. Okay, so Wiggly Worm. This is refreshing at 100 milliseconds. There's probably 1,000 data points per series, 3 series. 0 lag. You can actually resize this as it's streaming, and it works just fine. I'm particularly proud of it. Okay, I think that's that for that section. All right, histograms. Histograms and heat maps. Does anyone use any of these? Okay. So both of them represent distributions. A histogram represents a single distribution of an entire data set. And so it's 2-dimensional, right? You have buckets on the x-axis, and you have how much in that bucket on the y-axis. Heat maps are just multiple histograms over time. So if you take the histogram, it looks like this, and you flip it, and each of the length of each finger becomes a color, and this is at a single point in time. You end up with a, heat map, and they kind of look like this. Grafana's panels can aggregate from raw data, or you can actually feed them pre-baked heat maps and histograms. Prometheus has something new. So what Prometheus always had is classic histograms. Classic histograms is when you predefine a bucket, is that you say, here's my bucket for 5 millisecond latency, and that actually becomes a time series that it collects. And then you say, there's a 10 millisecond bucket, and then 5 second, 10 second, 60 second, whatever it is. And those are all time series, but you have to predefine them. I think that out of the box, it comes with maybe 10 buckets. So there are storage requirements for this that are actually pretty big. I don't fully understand them because it's more on the Prometheus storage side. But I guess all of these series have to kind of exist forever once you've set them up. There's something new called native sparse histograms. And they are much higher resolution. You don't need manual bucket configuration for them at all. And they are basically the same cost. There's a much deeper dive into them here. We're not going to go into it, obviously. There's a bunch of, if you want to listen to a bunch of math about how they pulled this off, it took a few years. It took a few years for them to work it into the existing architecture. We're going to make one. We're going to try to make one. So let's put this away. So what we're going to do is we're going to pick a color scheme. This is from D3, and we're going to do interpolate Inferno. So what these interpolation functions do is that they take this nice gradient and they take a 0 to 1 value, and it will return whatever value it is on this gradient, whatever color, hex color it is. So don't worry, I'm not actually going to write this code from scratch. It's already done. So it's actually pretty short. So this is a version of it that is just using basically HTML. It's using the document object model. These are the dependencies for the scaling from D3. The data is pretty simple. It's 50,000 cells. It generates 50,000 cells with random values. This is a seeded random generator, which means that it's random based on the seed. So it will always give you the same random, if that makes sense. So you could actually compare different random implementations. So the data, this is the gen data. Every time you call it, it's going to increment and generate a different random, but it only cycles between these 5. Here, let's see. So we do the data generation. We basically get the range of all the data using spreads, right? So you do math.min at.max. The range becomes this. Enter and leave count. This is just to give these, we want each of the cells to be hoverable, probably. They are in Grafana. So we'll bind event handlers to them that do something. If they do nothing, they might get optimized out by the JavaScript engine. So we'll have them do just easy incrementation. And there's really not too much here. This sets the style. It does some basic math to calculate column and row number from a flat array. And it does the interpolation of the color here. So I switched to the wrong. I have 2 Opera versions. Here we go. All right. We're going to pull up DevTools. DevTools are fun. Anyone use a profiler in DevTools to measure code? If you haven't, you're missing out. So we're going to click that, and it's going to give me an error. It's going to say rand is not a function. Why would it do that to me? Let's look at if it loaded everything. Oh, we're going to get a little debugging action. Okay. let's see. I won't spend too much time on this. One second. You know, it's funny that you see all these hacker movies where there's like this hacker guy and he's like this. You never see them like looking confused at a stack trace for like 5 minutes and like being like, what the hell is going on? Well, we don't have to do this, and we can actually do it in the Q&A if anyone ends up staying. I know this is way over. Well, it's not. I had an hour, so the Q&A might be a little short. But I think that these are probably all gonna, I will fix them later. Let's take a look at, we'll skip that, we'll leave that for later, but I did want to do the histogram demo, which is the actual histograms that do work in Grafana, because I wrote better code there apparently. You can see the difference in resolution here. It's pretty huge. So you actually can't really tell what's going on in this one. You don't really know that this is around 4 milliseconds, and then, because it kind of falls in between here. So here we have, I mean, there's probably 100,000 data points here, and here there's maybe a couple thousand. And you can see that, like, you could resize this all day long, and it doesn't lag, which is pretty cool. You can switch the, we can take a look at the different, this is actual live, like, infrastructure in Grafana and what it's doing. I've seen some pretty cool patterns in here before that are completely like if you compare these are pulling the same exact data, but you just get so much more clarity out of the bottom one. Sometimes they are not straight lines. Here they tend to always be straight lines. These are exemplars, by the way, these little zit-looking things. They're ways to get into the actual traces because heat maps are just aggregates. But you could collect specific traces to do investigations. So you could then query them with tempo, and apparently it's blocking me from doing that. So this takes you to a trace that tells you what was going on, and you can expand it, and you can do all sorts of stuff with it and look at the exact details of it. Let's not make a heat map, and this is the part we're not going to do because we didn't make a heat map. We did the demo. That's kind of it. If you guys stick around, I'll fix the heat map stuff, but not while I'm up here. But I do have some funny pie charts. It's funny because, number one, the pie charts are funny, and it's also the visualization that represents the least amount of data in the most amount of space. There's one data point here, and it's funny because we've been talking about rendering hundreds of thousands. That's it. Well, there's thank you, I guess. Thank you all for listening to me babble about stuff that I'm very passionate about, and you might not care at all about, but sat through it anyways.
So thank you for speaking. Any questions, even if they're online?
Yeah, Q&A. I will say that I can't tell you how to use Splunk data in Grafana because I don't know Splunk, for example, but I do know about other things.
So far, you're looking good. I'm not. Oh, there we go.
Yes.
So first of all, I didn't know about this solution, open source library. Thanks for that. Was great learning experience. I have a couple questions. Since it's a kind of a real-time experience with a probably a lag of 5 to 6 seconds max. So if we have like a big data source, like how are we going to compute the memory requirements and also the network bandwidth requirements that are required for this library to successfully run in our computer?
So I think, so most of the time, you're probably not going to be streaming raw data. That's just not going to be realistic, depending on what you're talking about, right? If it's one device, but if you have, if you have 1,000 of them, there are going to be limits to it. I would say try it. I would say try it and see what works, right? At some point, it's going to stop working well, right? We can't support 100,000 series streaming simultaneously at 50 milliseconds. I guess that would be my answer. And if there are performance issues, we will definitely look at them and try to fix them. But yeah, there's not really an easy answer to that because there's a lot, like on the front end, right? It depends on the data source. The data source itself might do some processing that's expensive. So we don't really know what memory requirements that data source is gonna impose. So like we only know what the panels end up doing, but up until that happens, we don't know.
And then I also have another question related to licensing.
Mm-hmm.
So I see like you have a GPL3 license.
It's AGPL, I believe.
Is it different from GPL? Actually,
Yeah.
it is. Okay, so currently I'm kind of using this MIT license and libraries related to like LangChain and the other ones which are related to GenAI. So they are mostly using either a Packet 2 license and the MIT license. They are kind of like very permissive and stuff.
Mm-hmm.
But when we like integrate such a solution into like GenAI applications, you have to move the license to the GPL3 or probably AGPL3 if I'm not wrong, because it's kind of restrictive.
So AGPL. So I'm not a licensing expert. I believe AGPL basically requires that if you provide your software externally, that's where it's accessible over a network to someone else, that you have to provide the source code for that software, right? So it has like what's called like a virality clause, is that it basically requires you can't integrate it into closed source solutions, right? Except for the actual issuer of the license. So like Grafana is able to use Grafana with other closed source code, but if you were going to use AGPL components that were written by Grafana with other software, that software has to be open sourced. I don't believe that it needs to be relicensed. It just needs to be open. But consult somebody about it who can give you legal advice.
Because
Yeah.
Amazon is also using the Grafana, right?
They are, but they have a contract.
They have a contract with Grafana.
Yeah.
Right. Thanks.
A question? Anyone on the stream? Check. Anyone on the stream have any questions? Now's your time. Can we cut back? Do you still have the other deck, the one they sent you earlier?
Yes. I might have closed out of it unless reopen.
Oh no, you probably have
We
to
might need to reopen a bunch of them, but it might be here. Hold on.
No. What's up? Any question? Oh, what's up?
So we were talking about streaming data frames with the circular buffer.
Hold on. Yeah. What was the question?
We were talking about streaming data frames in the circular buffer.
Talking about streaming data frames in a circular buffer.
Yeah.
So what is the need for circular buffers for the data
So there's a limit, right? We can't accumulate infinitely, right? So you have to basically cycle the amount of data in there. As you push data in, you have to move data out.
So this is used for rendering the data again and again.
Yeah.
This is also implemented in both.
So it's actually, I mean, it's not fully accurate. It's not a circular buffer. We basically just slice the front of the array off and push more onto it. So there's a limit. It doesn't do a true circular buffer. There was one before. We ended up removing it just because of simplicity. So it just does a slice.
Why couldn't we use like a sliding window other than buffer, like a buffer? Why can't we use a sliding window, like sliding window over sliding window over sliding window?
So I mean, I'm not sure I understand.
Like generally, like if we look at rendering video frames, they use 3 buffers, right? Like sliding window over sliding window over sliding window. For this, why can't we implement the same thing?
I think that, yeah, we probably need to look at the details of what you're asking. I'm not sure I understand.
Okay. So do you have something like a GitHub repo where I can follow this content? And,
So you can follow me on GitHub. There's so I actually wrote the library that Grafana uses, charting library. So you can watch that if you'd like. So the library itself doesn't have streaming functionality in it. It's just really fast at rendering, and you just give it data, and it will just render it. So the streaming is implemented on the Grafana side. Yeah.
so the streaming is implemented here, but not on the library side, right?
Yeah, the streaming is because the entire data pipeline is inside Grafana. Yeah.
So like what kind of like can this be integrated with Apache Airflow data pipeline? Or,
I'm not familiar with that, but probably. You can take it even.
So we recognize that some of you have tight train timelines, and there's a lot of questions. So let's give a round of applause for Leon. It was awesome, very deep. So thank you for coming and presenting your material. I did want to give a shout out to the venue, Aspen Group, hiring great engineers right now. We're looking for backend developers, front-end developers, SRE, and as well as DevOps. So if any of this is interesting, we use Grafana. We actually run it ourselves too because it's an awesome tool. It's beyond awesome. So you should all check it out. So thank you, everybody, and we'll stick around and have any questions. Anyone to stream, thank you for tuning in. Until next time, bye.